Uh, some of you might know me already. My name is Andrew. I represent the technical support of Galileosky. Today I will be having this webinar about creating flexible fuel control system with our guest from Wialon. It's Wialon expert Pavel. I will be holding the first part of our webinar, which will be about the configuration of the Galileosky devices to work with fuel level sensors, of how to choose different fuel level sensors, and how to connect them, and also how to filter and work with them in the EasyLogic tab. And then Pavel will tell his part about the Wialon side and how to work with fuel level sensors and create different fuel reports in on the side of the monitoring software. So hello, Pavel. I'm sorry,
hello,
but yeah, sure, yeah. Okay, so what will be my part in this webinar? I will tell you how to choose and connect different fuel level sensors to a GPS tracking unit. I'll tell you everything that you need to know about the sensor calibration of these sensors, how to use EasyLogic for fuel consumption and fuel control. And then Pavel will tell about basic settings of the Wialon software, features and advantages of fuel algorithms, and displaying results in reports. So before we begin, first, please make sure that you can all hear me and see me well, because as far as I can see, the quality from our side is pretty good. If you have or experience any troubles, please check your connection or check your settings of the PC and the speakers and so on. Talking in brief introduction into this webinar. It will last about 60 minutes. The recording of today's webinar will be sent to email to everyone who registered for this event, so don't worry if you have to miss part of it or whole. Doesn't matter. You will be sent the recording after the webinar. The questions can be asked on the question tab, and we will try to answer those after the main part of the webinar, so after the presentation. In order to ask a question, you can access the questions tab, which is with the question mark on the right upper side of your screen, and access the questions tab, where you can print and type the the issues that you want to discuss. So I think we can begin. There are different fuel level sensors. I'm pretty sure that you have already faced the majority of those. Still just a brief introduction into the theme. So the basic types of fuel level sensors are analog, frequency, and digital fuel level sensors, which can be connected via RS-232 or RS-485 interfaces. What are the basic features of those? Analog and frequency can be used with the discrete analog inputs, and analog fuel level sensors work with electric capacity of the sensor and turn it into voltage, so they send data in volts. The frequency fuel level sensors, as it's obvious, are sending data in sending data about the fuel level in frequency, so in hertz. And the digital fuel level sensors are more precise and work with certain protocols, exchange protocols, and send data via corresponding interfaces. So let's have a closer look at how to connect each and set each to work with Galileosky trackers. The analog type fuel level sensors, as I already mentioned, work with voltage level, so with the volts. You can see the connection scheme on the left side of the screen. It involves one discrete analog input of the tracker. For example, on this scheme we see a connector type of Galileosky 5.0, which has 8 different discrete analog inputs. So basically you can use each of these inputs for one specific fuel level sensor. being up to 8 field level sensors. The analog field level sensors are usually not quite expensive, but the precision with which the values are sent to the tracker can be lower than with the digital field level sensors due to different noises and due to the fact that it's simply measuring the voltage level on the wire. So the specific way of this field level sensor work implies that it will have less precision than digital ones. The setting is made on the tab Settings, Inputs, Outputs, and involve using filter type as mean value. That means that you will take certain amount of evaluations of the voltage and keep an average of that. So filter length is actually the number of times that the value is got and is made as average value. And then on the device tab, you will see the value of the input, the corresponding input, in the corresponding tab. You can also choose in the protocol tab the corresponding input to be set to the server side. Frequency field level sensors are a little bit more precise, although still lack in precision in comparison with digital field level sensors. Here the settings are a bit more, there are a bit more settings, so there are 2 steps to be made. The connection scheme is pretty much the same, only here if the shifting of frequency signal to the plus contact of the field level sensor is not provided by the manufacturer of the field level sensor, then an additional resistor with the nominal of 10 kilo ohm will be required to be used as shown on the screen, so in the scheme. The settings are the following. The first step is pretty much the same as with the analog field level sensor, only this time the filter length will be greater. It will be 50 or more. In that way, we will provide maximum precision of the average amplitude of the analog signal. After we measure it for some time, like several minutes, and get the average value from the field level sensor in volts, we use it as discrete signal range for the frequency filter. So we change the filter type, as you can see in the lower part of the screen, to frequency count, set the filter length 1, and set discrete signal range, due to which the frequency will be counted as the amplitude that we calculated before. In case if the manufacturer gives the maximum or average amplitude, you can use that instead of using step 1. But as the manufacturers not always provide such information, sometimes you need to do it by yourself. The digital field level sensors are a bit simpler, I guess, in connection, because here you don't need to set much. The connection scheme you can see on the upper side of the slide. So it's a standard RX to TX connection, so receiving to transmitting contacts, and of course the G&D contacts, the ground contacts, should be connected. On the settings tab, so settings digital inputs, we set the peripheral type as field level sensor in case if the field level sensor uses FLS protocol. So just to make sure, for both RS-232 and RS-485, we have integrated in the firmware only LLS field level sensor protocol. In case if your field level sensor uses a different protocol, the integration is possible, usually using the EasyLogic algorithm, which is a tool for broadening the functionality of the trackers. For example, we even have an example of such script using the Modbus protocol. So if any don't have it yet, and needs such protocol example, algorithm example, we can send it afterwards, after the webinar. This is how the data is shown. So here you can see that the digital field level sensor not only gives us the value of the sensor, it also shows the temperature of the fuel, which is quite crucial when you have to calculate the fuel consumption or work with the fuel level depending on the on the season, like the temperature outside and the state of the fuel, because you know gasoline or diesel is different in winter and in summer. The troubleshooting tab also gives us the messages from the fuel level sensor, the same that we see here. And in order to send it to monitoring software, we have to select the corresponding RS-232 port, because many of our devices have two ports, RS-232 and RS-232. So the one that you use with fuel level sensor, you select it to be sent to the server. RS-485 is a little bit more tricky, because here we don't necessarily have to connect only one fuel level sensor. And yes, for RS-232, as you know, the interface implies that you can connect only one fuel level sensor, no more. RS-485 allows to connect more than one fuel level sensor, to be precise, up to 16 different, up to 16 fuel level sensors. The connection scheme is pretty much the same, only here we use the RS-485 contacts, and the connection is direct. So it's not RX to TX, different contacts in RS-232 part. It is A to A and B to B connection. The ground contacts, of course, are connected as well. The peripheral type is chosen as Galileosky camera and FLS dosimeter. What is interesting here is that for each fuel level sensor we have a special tag, and not only for the value but also for the temperature. Well, for RS-232 it's the same, but here what is important is that if we use devices before 7.0 or base block like 5.0 or 4.0, which have dynamic archive type, we have to choose to turn on the dynamic archive, otherwise we'll receive only the first three values, like you can see FLS 0 value, FLS 1 value, FLS 2 value. All the rest will not be sent. The connection itself, yes, and this is how we can see the values from the sensors. So they are also shown on the device tab. We can see corresponding data in the troubleshooting, and in diagnostics we only need to choose one RS-485 port to show all the messages from all the devices connected via this interface. As I already mentioned, here on the right side you can see that dynamic archive structure is required for more than 3 fuel levels. I had small technical problems. So continuing, the most important part here is that the RS-485 fuel level sensors should be connected in a specific way. So you can see that the more fuel level sensors there are, there should be used a bus, RS-485 bus, not connection of each fuel level sensor separately, because if it happens separately, there will be trouble with the receiving different info or different data from different fuel level sensors. There will be conflicting with each other, and data losses can be happening. So it's important to connect them one by one. So create one general RS-485 bus with A and B contacts, and have a shortcuts to each of the fuel level sensor with a resistor of 120 ohm in the end. From the device side, the resistor is already applied, so you don't need to use it from the tracker side. It's already inside the tracker. As you already know, I guess, we, apart from the logic tab, also have a special filters tab, which looks pretty, but it allows only to apply certain filters to change the data that we're working with. Such filters can be applied for working with field level sensors as well, and let's just have a quick look at how we can do that. The most obvious choice will be using tar filter, because it allows us to create a tar calibration table, which converts the sensor values into real values, like for example in liters. You can see the example on the screen. So we create get and save parameters. We create the filter itself. That's pretty easy. That's just 3 different actions. And then we start filling in this calculation table. The calibration process is usually pretty much the same. After we install the field level sensor into the fuel tank, we well, the fuel tank is usually empty because any cutting into the fuel tank when the fuel is inside is flammable, so it's quite dangerous. So we start with measuring the empty tank and what values are coming from fuel level sensors when the tank is empty, and then start adding a certain amount of fuel, for example 5 liters or 10 liters each. And at each stage, when we add the fuel, we calculate, so we measure the current values from the digital fuel level sensor and enter them into the calibration table. So in this way, we the smaller the steps of the liters, the more precise this table will be. After that, we simply save the table, save the fuel level, the filter for fuel level sensor calibration, and upload it to the tracker. From that, the tracker starts to automatically convert the data from raw data into real values. Apart from usual tar filter, we have a specified fuel tar filter, which, as you can see, have 2 inputs, fuel sensor and temperature. This is, as I already mentioned, for specific filtering the fuel, so it will use the temperature that is on the RS2320 temperature value, and also it will use the type, because there are 3 types here: the gasoline type, diesel winter, and diesel summer. They all have different physical features of liquidity, so that will help us to work with the fuel more precisely. The rest is the same, so we set the fuel level sensor value and liters, so the adjusted value. So the rest is the same as usual tar filter, but the amount of, well, the specification here is more up to the object. Apart from that, we can also use the moving average filter, which is pretty much the same as the filter type mean value. So it takes a number of calculation and gets us, so gives us a result, average result of these number of calculations. So that's helping us when, for example, the values from fuel level sensor are jumping, like higher, lower, and we need to give them more stable value. So basic advantages of using the filters tab and the filters from filters tab is that it's pretty fast to create and to install on tracker, so you don't need to do that on some remote server when you can actually even not have internet. You just have you can have laptop, tracker connected to the vehicle, and field level sensor, and you can set the work of this field level sensor just on the object. So that's actually the second advantage, is that it can be constructed while the sensor values are changing in real time. we can take external factors like fuel type or temperature into consideration when we calculate the values, and we can save the filtered fuel level sensor values into any input value. So we can not only use the input that we're taking the values from, we can use any input that's not used currently. For example, save the digital level values into analog value, input, just to receive both raw data and filter data. And the last way to get fuel level values into the tracker is reading them from CAN bus. So I will not give you a detailed instruction on how to do that. We have videos, corresponding video about how to work with CAN scanner and how to find fuel level in the vehicle. The principle is basically the same as with the calculation table. So you evaluate the current amount of fuel in the fuel tank, look for more or less for values that in the CAN bus that fit to this value. Then, for example, add some value, check what values changed when you were adding these values, and so on. So the CAN scanner is a powerful tool that allows to find different data in real time, and fuel level is just one of them. That's not the only one. After we find it via CAN scanner in the CAN bus, it can be in liters or it can be in percent. Usually, well, the manufacturers decide differently or what is more convenient for them. We can record it into a certain protocol tag and also send it to the server for further work with them. So basically that's it. No, I'm sorry. That was about CAN scanner, and also we can work with the fuel level values in EasyLogic. So after we decide and after we set how we get the data to the tracker, we then can also work with this data and even set different reactions depending on what is current fuel level and so on. What are the usual ways that our clients use EasyLogic algorithms to work with fuel level? These are, of course, fuel drain control. So if you are being robbed of fuel by, I don't know, by some external convenience, or by inside, so by the driver, doesn't matter. Still, it will help to identify if there is a fuel drain. The clients can set to send dispatch notifications when undesired activities with fuel are done. For example, refueling in a place that is not allowed. The limits for different drivers of fuel consumption can be created, and also we can control what fueling stations the driver is using for his vehicle. So these are the examples of how and what we can do in EasyLogic. This is pretty easy. All the examples here I will not also cover in details. You can further look at the algorithms. They are pretty much applicable, and you can use them as an example to create your own. So the main idea of fuel drain control is that we check each 20 seconds how much fuel was spent, and if we see that the fuel spent exceeded 50, some value of 50 in 20 seconds, that means that the fuel consumption is too high to be natural, and we send SMS about the fuel drain on a certain car. So we can set any text in the SMS message. We can set the driver ID, we can set the license plate of the car, and so on. So the dispatcher will get notification once the fuel drain is done, and the fuel level data can be gained from external or internal field level sensors like canvas. We can set a flexible limit for different drivers depending on the vehicle type, depending on the driver experience, and so on. Usually the limits are set per day, so per 24 hours, and automatically restored after new day starts. And we can also change the limit automatically due to different conditions. For example, here is a pretty complex algorithm that sets the field limits. One moment, I will. That sets a field limits for two drivers here. Then we check if a new day arrived. If not, these are two branches for two different drivers. So in each branch, we check if the trusted key was attached to the reader inside the car, check if there is any fuel limit left, so if he didn't exceed or just drain his fuel limit for the day. If he exceeded, then we do not open the refueler, access to refueler. If he does have some fuel limit left, then we record current value of fuel, open the output, wait for 1 minute, and then deduct the spent level of fuel that he spent while refueling from his fuel limit per day, and then check again. So pretty easy, and if needed, we also can send you later. We can also control fuel stations. So by geofences, usually here we use polygonal geofences that we already discussed on the previous webinar, one of previous webinars, to be honest, in January, if I'm recalling correctly. So the main idea here is that the algorithm will automatically define specific fueling stations depending on the geofences. Here, different partnership programs between monitoring service and fueling company can be applied. The system is able to work not depending if there is any GSM network coverage or not. So the tracker will work automatically by the GPS, so by the coordinates and by the settings applied already. It doesn't mean any confirmation via GSM, GPRS, or any other network channels. And it is a kind of alternative solution when monitoring software is not used or not supported. These were the basic principles of how to work with Galileosky and fuel level sensors, and use their values with filters and work with them in EasyLogic. Now I would wish to pass the word to our guest, to Pavel, who will tell what can be done further on on the Wialon software program, and tell all interesting things about that. So, Pavel, you can have the word.
Hello, everyone. Please let me know if you can hear me. Please let me know if you can hear me. Yes, okay, great. Great. So let me first thank you, Andrew, for the marvelous presentation. And my name is Paul. I'm a Wialon trainer in Bhutan, and I'm going to cover the basics of fuel in Wialon. I'll be focusing on the presentation itself, on the interface presentation itself. Therefore, I'm going to switch off the video to save some traffic. Okay, hope you can see my screen now. Tell me if you can see my screen. Okay, good. Currently on the screen, I'm displaying a final result of what you may achieve using Wialon in combination with the Galileosky devices. So you can see a track, a unit track, along with some markers, for example, a fuel theft marker over here. And at the bottom part of this window, we can see a number of tables and the summary data of how many fuel fillings, fuel thefts were detected and what was the amount of the fuel filled and stolen. So this is the result we want to achieve, but here comes a question how we can do. Supposedly I would have a unit, a new unit, that is already set, that already has basic settings like a device type and unique identification number is already here. So what we need to do to start working with the fuel? We of course need to create a fuel level sensor. For that, let's navigate to the Sensors tab. Click New to add new one. But let me just explain a little bit on the sensors I already have. These are the very basic sensors that I might use during this presentation. For example, the engine ignition sensor, it's already here. Create a fuel level sensor, give it a name, the sensor type. In my example, it will be the fuel level sensor. Please mind, it's a very crucial step to select a correct fuel sensor type, because in Wialon, each sensor type initiates a certain algorithm. So this is actually how the system is going to interpret the readings from your real sensor. Choose wisely. Next, we need to define the parameter. And I also need to point out that as Wialon supports a huge number of different tracking devices, they also use different communication protocols, and the parameters may differ. Luckily, we can check which parameter is required by just opening the Guten hardware page and searching for the required device. In our case, it will be the Galileosky version 5. And apart from the additional information like device's capabilities, we can check parameters. In the parameters, we see the description of each parameter that can be sent by a tracking device, by a following tracking device. What we are looking for are the fuel readings, in this particular case, in the parameter RS485. So let's copy it and use it in our newly created sensor. So I just input it into the parameters field. We can click OK to save the changes. Again, click OK to save the unit's properties. And basically check if the report is working. But before that, I'm navigating to the Messages tab to see if the data was exactly received or not from that particular new truck. So I switch to the data messages, raw data. I'm not displaying any sensors yet. I want to check if the raw data is received. Let's check. For the tests, I'm using filtration field to find the exact parameter and to make sure it's received in the system. And we can see that it's present in the messages, and so my choice was correct. And the sensor was set up correctly. Let's jump back to the unit properties and make some more settings. Apart from the sensor, we need to actually activate it in the fuels consumption tab. So I'll go to the fuel consumption, activate fuel level sensor, and in my case, I'm going to also apply some filtration from the Wialon side, from the software side. Although Andrew mentioned there is a possibility to use this similar approach on the device side, there is always a software option. In my example, I already know what was the filtration level that fits better. I'll be using filtration level of 5. Please mind, the level should be smooth, but not too much. Otherwise, you're going to get errors, or the fuel level will not, the fuel thefts and fuel fillings will not be detected. So let's save the properties and navigate finally to the reports tab, where we have a predefined report on the fuel, and again execute it for the newly created unit, of course, and check the results. So here currently we see a lot of thefts and a lot of fillings. This is due to the current settings of the unit. And we can get even more details if we jump to the chart. And check what are the fuel levels. At least we can check how the filtration affects the fuel level and see raw data versus processed data. Let me disable all the backgrounds and markers just to show you how the filtration itself affects the fuel level. So right now we see only two lines, the raw data, which is the blue line, and the processed fuel level, which is the purple line. And we can see that the filtration actually affects it significantly, and some drops are eliminated thanks to the filtration, of course. Then we can also, let's jump back to the chart. I wanted to check one of the fuel thefts on the specific date in the first place. So, for example, here we have a fuel theft on the 19th of May, and also another one. The fuel theft was detected probably during the idling run. As far as you can see, there is no speed. I switched off the parking background, and we can understand that the engine was working, but no movement was detected, and still Wialon detects a theft. Maybe it's a false theft. So how we can actually work with such thefts? Here I need to explain that in Wialon we do have two different algorithms to process fuel consumption. I'm switching to another presentation. On this chart, you can see the fuel level on the timetable, along with the stops and trips intervals. So the first algorithm, the first fuel consumption algorithm, is based on basically trips. It's called mileage-based algorithm, and it takes into account difference between two consecutive trips. So Wialon checks what we had at the end of the previous trip, like here, shown with the orange circle, and what we have at the beginning of the next trip. If there is no difference, then no thefts or no fillings are detected. But if fuel drops, like shown here with the red line, or vice versa rises, displayed with a green line, then a fuel theft or a filling may be detected, taking into account minimum fuel theft and volume and fillings volume. So this algorithm is pretty simple. As far as you can see, it just takes into account what was the fuel level between the trips. The approach is just very basic one. But then what happens if, for example, the engine is working during a stop? Like shown here with the blue line, the engine is working, the fuel is decreasing. Then we will be detecting a fuel theft, which is not correct because it is idling. What happens if a unit moves and also additional equipment is working during the movement, and the consumption also rises. So then we cannot detect if it's a theft or a consumption. Again, another situation, if there is a trip and the abnormal consumption is detected, so it won't be marked as a theft, unfortunately, when we're using the mileage-based algorithm. For that, for such situations, we can use another algorithm, which is the so-called time-based algorithm. When we apply the time-based algorithm, we also take into account additional equipment, idling runs, and of course the consumption rates. So such algorithm fits better for the stationary units, for the different kinds of constructions machinery, for the situations when the mileage-based algorithm was not giving you good results. And we can detect if there is an abnormal consumption and say it's a theft. So basically, when a time-based algorithm is applied, Wialon compares real consumption with a mathematical model. And here comes the question, how we can set up this mathematical model. So let's jump back to the unit settings. First of all, we need to enable, in the fuel consumption, we need to enable the following options. Time-based calculation of the fuel consumption, thefts, fillings, and in my case, fuel theft in motion. Then in the sensors tab, I also need to add the rates, the consumption rates. For that, I'm going to use Math Consumption Wizard. And I already know these rates for the following truck. For the idling run, it is 6 liters per hour. For the urban cycle, starting from the 36 kilometers an hour and up to 80 kilometers an hour, it will be 42 liters. And 40 liters for the suburban cycle. Okay. Once we've added the rates, the system creates this additional sensors itself, and it also adjusted the existing sensors. The one that I already mentioned at the beginning of the session, the ignition sensor. Now we have here the consumption rates as shown on the screen, 6 liters per hour. Okay. And basically it already starts working, so we can execute a report. But before that, I need to, of course, add one more thing to the fuel level sensor. I skipped this point at the beginning. It was about the calibration table. As Andrew mentioned, it's possible to use calibration on the Galileosky side. So maybe it's not needed if you already applied on the device side and in Wialon you just receive liters or actual volume, then it's not needed. But like in my case, it's definitely needed. Therefore, I'm going to the sensor properties one more time, calculation table, and the procedure is pretty much the same as was shown by Andrew. But in Wialon, we just use the X and Y pairs where on the right or in the Y column, we just add liters or output values. Let's add more lines. For example, 0 liters, 20, 30, and so on, etc. And then we need to add an output value, input value that is received in the parameter itself from a tracking device. So let it be the following value, for example, like this. we can proceed this with this setup manually, or import the table, the calculation table, from a file. Luckily, I saved one for myself, and here's the special tool that allows you to import a CSV or text file with the calibration table that you already have. So I imported the calibration table and simply click generate to get the calculation. Jump to the chart to see how it works. And if it's needed, you can cut off any values that are below, for example, 0. In my case, you can see how the chart goes down below the 0 value. For that, just use the lower and upper bounds, like that. And enable option apply to the calculation, because I'm going to apply these bounds for the leaders, not for the input values. Now let's check how the chart looks like, and we can definitely spot the difference. It shows us that the values below 0 are being cut off and are not used in any reports, in any notifications. So this is how you can actually import a conversion table, a calibration table into Wialon, or just manually input it to the sensor's properties if you are not using it from the device side. So now we can finally save it and run the report one more time. Now the volume, the theft volumes and the filling volumes will be a little bit different, of course, and much closer to real situation. But what is more, if we check the charts, the field chart for the same period of time, so we won't see here any thefts, no thefts, because the unit was working, because the truck was working, engine was working, the consumption, the fuel was consumed by engine, and the rates were not exceeded, no limits were broken, so the theft is not detected. Instead, we have here consumption. In the first idling run, in the second, we have consumption. No more thefts detected when we apply the time-based algorithm. So as far as you can see, different algorithms can be used in different situations. And one of them, the time-based algorithm, helped me to eliminate false thefts for this truck. Although I used it for moving objects, it's also possible to combine different approaches in Wialon to get a required result. So let's briefly go through the steps that we need to fulfill before we can control fuel. Just to remind you again, we need to create a sensor in the first place, define a parameter in this sensor, add the calibration table, if it wasn't added on the device side, of course, activate fuel sensor in unit properties, and apply filtration if it's needed. Again, if it wasn't added on the device side. So now I will probably jump to the reports creation. We already have a report that is pretty good and shows the results. It displays them on a map. It shows the charts. It shows tables. But how we can create something similar from the scratch? Just go to the reports tab, click on new one. If you want to display a track on a map or markers, go to the settings, expand the map output options, apply trip routes, fill-in markers, and theft markers, for example. And go back to contents, add a new table, and decide which table you want to get, which interval you want to control fuel in. For example, you want to see the fuel in trips, and just select trips table, enable the columns beginning and just some basic data: duration of this trip, mileage of the trip, and of course fuel consumption by fuel level sensor, and maybe average consumption. Click OK. So now we have trips table with consumption. Add another table, and if you want to work with constructions machinery, select engine hours. Define what you want to see in this report, in this table, beginning and end, for how long the engine was working. So we need to see engine hours, maybe idling if it's a moving object, and of course consumption by fuel level sensor and average consumption. Okay, to add this table. Now we can also add a chart that we used in a sample report. In Wialon, we do have different types of fuel charts, but let's just stick to the very basic one, the regular type, and add the speed data, and of course the fuel readings, the raw readings and the process data to compare them. In case of any fluctuation on the chart, we'll be able to see if there are any jumps during a movement or just during an idling run or parking, etc. So it's pretty useful. Hit OK to save it, and finally we get the report. I already showed you this report, so let's just execute this one another time, and a couple of words on what we can get. For example, here I'm displaying trips along with the consumption for for 1 month. Yes, for 1 month probably. And we can see consumption from the sensor, so the real readings, over 3,800 liters, and compared to the mathematical model only. The difference is there, of course, but it's not significant. Taking into account we're using the very basic setup of only the fuel engine sensor and the fuel level sensor. If you do have any additional equipment like weight sensors, temperature sensors, maybe anything else that just detects if additional heater is switched on and so on, then you can also add it to the mathematical model, and the results will be even more precise in reports, in notifications. But still, we have a pretty good result over here. Only 200 liters difference between real readings and mathematical module for over a month. This is basically all I wanted to show you in terms of initial Wialon setup for the fuel level sensors, fuel consumption tab, and an output in the form of table reports, markers on a map, and charts. Now probably we'll have questions part. Andrew, can you
Yes,
jump in?
thank you very much for your part, Pavel. It was quite interesting and informative. Yes, we have a couple of minutes to do the questions. I think you can stop sharing the screen. Yeah, thank you. And yeah, so while you had your part, I had some time to look through the questions. Just wanted to answer some answered in writing, but I wanted also to answer the most, I guess, interesting here vocally. So, question from Amir about the difference between digital fuel level sensor and fuel level sensor in the CAN bus. The basic here is that fuel level sensor digital external is of a more accuracy, so it's more accurate. It gives better values, and well, it's less conducted to different noises on the wiring. But the disadvantage here is that you have to actually install it, so you have to drain the fuel tank, you have to cut into the fuel tank, and so that's just some job that needs to be done. The CAN bus sensor on the other side is not as accurate, so they are usually quite cheap. They are not even these long analog field level sensors. They're simply swimming on the fuel level. And here is just the convenience that you have a sensor already installed in the CAN bus, which makes it easier to connect to and easier to find, but at the same time you lack in accuracy. Then next, about the ultrasonic field level sensors. Well, we had some experience with that. Yes, they also sometimes might lack in accuracy, but as far as I know, we have integration with one of them, and we have made it for one of our clients. So I'm pretty sure that John here already mentioned it about the GUT 810. So they can be tried, and this is an existing option to work with. Uh, uh, Next, how do I reduce false notification of field fillings and theft? Well, Pavel partly have covered this point here. I just wanted to make clear about the thefts in moving or standing. Many here mentioned that when the vehicle is not moving and the fuel is draining, that is fuel drain. Well, that is true partly, but it doesn't only mean that the fuel can be drained only when the vehicle is standing. We have heard, well, actually, a number of accidents, well, not accidents, a number of issues when the fuel was drained during movement. So that is quite important to control this, well, either by the algorithm side or by the monitoring software side, not depending on if the vehicle is moving or standing. Usually it can be this or that way controlled by the amount of the fuel spent. And well, of course, when it's standing, it's easier because there shouldn't be close to none of fuel drain. But when it's moving, there is this difference between normal fuel consumption and fuel drain. So just the level of fuel level getting lower, here the rate will be higher if it's a drain.
Andrew, probably let me also add in a little bit
Sure.
to Lauren's question. I wanted to clarify who this question was addressed to the Galileosky or to the Gutam team, because I think it was addressed to Gutam. And this question about notifications on the fuel, fillings and thefts, and we need to understand if we want to control a moving unit, a moving vehicle, and we don't need to receive fuel thefts and fillings during movement, then just disable the time-based algorithm that I already covered, and instead use the mileage-based algorithm. When we compare the difference between the fuel levels within the parkings. So it's pretty simple. But if we're talking about constructions machinery, then it's a difficult question because they may move slowly and still consume fuel. In this case, we need to check if there is any trembling, maybe applied filtration on the device side or in Wialon. Again, if we're using Galileo, then you just add the filtration on their side, may add the filtration on their side. And we need to check a particular situation. What happened? Why a notification triggered? Was the filling with theft, etc. So it's a matter of a particular case you have, And if you want, you can send us details for additional consideration. So just clarify what exactly happened, where, when, and what were the conditions, if it's a moving unit or a construction vehicle, etc.
Sorry for speaking without sound. So again, thanks very much, Pavel. So I see next question to the Galileosky team. How many trusted keys in your terminal can hold in memory? Our trackers can work with either internal memory. If you don't use micro SD card, that is up to 8 trusted keys. If you use external micro SD card connected to the tracker, the amount is up to 1000 keys. So up to 1000 trusted keys can be stored on the micro SD card. That is used for identification and further work in algorithm or any other way. Then, I see that there are actually quite a lot of questions about the fuel filling and fuel theft on the Wialon side. Well, I think they were actually, at least I saw them at the beginning of your presentation, Pavel, so I don't know. I guess that you already covered them during the presentation. So please, if you see any that you haven't yet answered, um, you can mention
I'm trying
those.
to go through these questions, read through them. For
Mm-hmm.
example, Alvaro asks, what happens if a vehicle has 2 fuel tanks?
I think here
It's a
we
basic
can.
question, probably, yeah.
Yeah.
In Wialon, you can combine 2 fuel sensors and more, and make one summary sensor if it's needed. So again, it depends on the actual situation. You can combine them and get the average of these 2 tanks. But if they are connected, then yes, average works. If they are not connected, then you can use them both separately and get fuel thefts and fillings for the first tank and for the second separately in reports and in notifications. So that one is probably covered.
Yeah, and I just wanted to add from our side that that is also possible to do via the filter step or easy logic algorithm. So it can be done either on the monitoring software side like Wialon or by from the device side in Galileosky trackers using these algorithms. So both ways are possible to do.
Another question, pretty similar to the one that I've already answered. One more thing, if the truck is moving and then fuel theft has come, then how can we confirm that fuel theft? Okay, so detect theft during movement. This is the question. There is an option to detect theft during movement in Wialon. It's just one little checkbox. You enable it, and then you start to take into consideration any intervals with the speed. So regardless of the movement, we consider any fuel drop as a theft. And again, you can apply time-based algorithm and add the consumption rates to say if it was an actual theft or if it was consumption. So it depends on the vehicle you have, on the unit you have, and the working conditions. If you do need to detect thefts in movement, there is one little checkbox. Probably you'll need some more settings, of course, and more details for this situation. And
Okay, so I can see a question from Mr. Alconas. He asks how to get calibration data of each vehicle type and is this standard? Well, actually not, because that depends on two types, that on two points. That depends on the fuel tank used on the vehicle, since you might know that the fuel tanks are not usually of ideal form. They can be they can be more wide in the beginning and more narrow in the end, or vice versa. So the calibration usually is done bad connection from my side. Okay, can you see me now? Can you hear me now? Okay, good. So, one more time, sorry for this technical disturbance. How can you get calibration data of each vehicle type? Is this standard? That all depends on fuel tanks and their forms, and that depends on the types of fuel level sensors, since they have different standards for them. The vehicle have different volumes of fuel tanks, different forms of fuel tanks, so no actual standard is existing, at least as far as we know. And it is always better to do it manually, because the accuracy level of the calibration will be higher if you do it by your own. Okay.
There are some more. I can see some more questions probably on the Wialon software. I think we can answer all of them. Just redirect them to the support@bluetooth.com, because most of them are general questions on how filtration can be applied, how calculation table can be added, confirm the filling time, for example, and so on and so forth. So I don't see any like specific questions.
Well, I see a question from Yogesh Verma. He asks also if one tank is 20,000 liters and it's distributing 1,000, 2,000 per day, how can we differentiate between fuel theft and distributing? Well, you see, Yogesh, here the thing is that if you look at a report per day, of course, it might be hard to notice. But the messages arrive to monitoring software usually with a certain period, like once per minute, twice per minute, and so on. And when it's a fuel drain, so it's a fuel theft, the level of fuel consumption is a lot higher than when it's a distributive of, well, per day. That is why you can identify the theft by the rate of how the fuel is consumed. I guess from the monitoring software side, like from Wialon side, it's pretty much the same, right? So it's looking at the rate of fuel consumed.
I'd say that it's the matter of the approach itself, the initial approach. If you're looking with a fuel tanker of 20,000 liters, probably to dispatch fuel, it's better to use the flow meters and to control thefts with the fuel level sensors. So it will be a much more efficient approach than just using fuel level sensor for everything, for fuel thefts and for fuel dispatching.
Yes, that's also true. Okay, I'm afraid that our time is almost gone. So thank you very much for your attention. Thank you very much, Pavel, for your participation in today's webinar. It was very informative and interesting to hear. We will try to answer the questions that were not answered now during the webinar in written form after the webinar, so tomorrow or today partly. I thank you very much for your attention and participation, for your questions. It was a productive webinar. So it was a glad I was glad to have this webinar today. I think Pavel also again, thank you.
Sure, thanks for the participation to all those who joined this session, and thank you, Andrew, for the demonstration of the Galileosky capabilities.
Yes, sure.
Hope we will be able to answer the questions together, maybe, because I can still see a lot of questions to the other.
Yes. Okay, to all of you, see you next webinar, and have a nice day, and goodbye, everyone.